Okay, students, in this video I am going to explain example 1.20, which is very important problem. They might ask in 5-mark question. Check whether the function f of x is equal to x mod x defined on this interval minus 2 comma 2 is 1 to 1 or not. First we have to check the given function is 1 to 1 or not. If it is 1 to 1, find a suitable codomain so that the function becomes a bijection. That means for what kind of codomain this function becomes a bijection. That means bijection means what? It has to possess onto also. It has to become onto also. So that is the thing they asked. Okay, first you have to check the given function is 1 to 1 function. Then you have to they are asking for what suitable codomain it becomes a bijective function. Okay, simple students, but you have to understand clearly. So previous videos also I told whenever modulus x is there, you have to go for the definition, because modulus of x is minus x when x less than 0. That is equal to x when x greater than 0. So f of x we take in this mod x also there. So whenever mod x when x less than 0, mod x is minus x. I told so many number of times. That is equal to x greater than or equal to 0. So accordingly the function changes. How it changes now? You replace this definition. F of x is equal to x into mod x is minus x when x less than 0. So you put minus x for mod x. So it becomes minus x square when x less than 0. Negative for negative values of x. F of x is equal to x into x when x greater than or equal to 0 for this part. For this part, x into x. Why? Because this is x. Mod x is x. So x into x, x square. So greater than or equal to 0. So you replace this given function as like this. F of x is equal to minus x square, is first one, when x less than 0. When x greater than or equal to 0, function value is x square. So while testing for 1 to 1 also, you have to test for 4 cases, but 2 cases it will be failed. At least you have to test for 2 cases. Okay, so what are the 2 cases that we are going to test here is, first one, when x less than 0, y less than 0. Okay, similarly x greater than or equal to 0, y greater than or equal to 0. You understand? When x less than 0, y less, both are less than 0. Like this, first part. Next, both are greater than or equal to 0. If you test these two, more than enough. Okay. So to test 1 to 1, I already told f of x is equal to f of y. If x is equal to y, then it is a 1 to 1 function. So f of x equal to f of y means minus x square is equal to minus y square, because this case now it is. So I have to put minus x square. Again for this one I have to put minus y square. So from this minus we get cancel. X square is equal to y square. So x is equal to y. You cannot take a negative value. X is plus or minus y. Not necessary, because it is less than 0. Minus into minus becomes positive itself. So minus, if you cut it, x square is equal to y square. Even if we take minus value, minus x the whole square, x square only will come. Minus y the whole square, y square only will come. So x is equal to y from this one, if you take the positive square root. Okay, so this case it is 1 to 1. Second case, x greater than or equal to 0, y greater than or equal to 0. So same, here also f of x is equal to f of y. So x square is equal to y square. There is no negative sign here, because this definition, x greater than or equal to 0, this definition, x square. First definition is this one, minus x square. That's why I put minus here. But here plus x square is equal to y square. So x is equal to y. So from case 1 and case 2, definitely f of x is 1 to 1. That means we tested for all the values of x defined by mod of x. Okay, in your textbook they given some other explanation, but this is very easy to understand. Okay, students, 2 more cases also might come, but you need not check. Positive, negative, positive, you need not check. Those values will not come under this interval. So bijection, how will you prove this is bijection or not? Means, listen carefully student, this is very easy. We did example 1.19. See here, minus 2 to 2. In between so many values might be there, because this is interval. 1 might be there, 0 might be there, 1.9, everything is there. So for what value of codomain, என்ன வேல்யூ கோடொமைனுக்கு கொடுத்தா இது வந்து ஆன் டு ஃபங்க்ஷன் ஆகும். ஆன் டு ஃபங்க்ஷன் ஆயிடுச்சுன்னா பைஜெக்ஷன் ஆகும். அப்போ வந்து இதோட மினிமம் வேல்யூ மேக்ஸிமம் வேல்யூ மட்டும் டெஸ்ட் பண்ணால் போதும். ஸோ ஃபார் எக்ஸாம்பிள் f of -2 into mod of -2 because x mod x function value -2 into mod of -2 only because this mod x always returns positive value minus of -2 so minus into plus minus so -4 so for -2 this is -4 so -4 oda pre-image -2 similarly f of 2 is what 2 into mod 2 because function is x mod x 2 into mod 2 so 2 into 2 4 but here -2 into mod of -2 -4 so 4 oda pre-image 2 okay so if the domain is codomain is -4 comma 4 the function becomes onto because this is the least value this is the greatest value so f of x is bijection from -2 to 2 to -4 to 4 see in example 1.19 we did only this part as one problem okay b set how will you find b set same model b set is this one -4 comma 4 same model we did example 1.19 but extra thing what we did here is this part so this part is extra so students listen carefully one more time first you take f of x as minus x this one mod x then it becomes minus x means x less than 0 definition of mod x that's it that is only x and x greater than or equal to 0 then f of x becomes minus x square when x less than 0 x square when x greater than or equal to 0 so this is a function redefined we redefine the function whenever mod x is there we saw in Goff and Fogg also you should redefine the function then two cases x less than 0 y less than 0 then you can prove x is equal to y like this similarly x greater than or equal to 0 y greater than or 0 x is equal to y like this so from both the cases it is 1 2 and if you put -4 comma 4 in codomain it becomes onto once it is 1 2 and onto it becomes a bijective function okay students so important problem very very important please concentrate on this problem so if you like this video please subscribe this channel okay bye